Okay, guys, that last video looked like it worked. I just want to make sure you guys kind of like refresh everything. So let's look at our switch. Just want to make sure that you guys see what you need to do to make this work. Okay, here's our switch configuration. All I did was I added, this is the one I added the encrypted password. No IP domain lookup. VLAN interface 1. Now it doesn't show no shutdown because it's not a thing. But make sure you put in the no shutdown command. If it was shutdown, it would actually say shutdown right here. So no shutdown, let's get rid of that. Our default gateway is right here. And then line con 0 and VTY. Our server, which we're still trying to make sure our services get pushed out to the remote office. We made that 250, 10.0.0.250. Our clients, 4, so 3 and 4. So 1, 2, 3, and 4, and 250. And we're hoping to get this guy to be able to check our HTTP server over here. That's our goal, putting in routing protocols. And the router. Okay. Host name, enable password, still hello. Loopback address is configured. Interface. If you guys look at that and you're confused why I used that, for a loopback address you can use that. That specifies a address, and that one address is a network unto itself. Okay. So you can actually use every bit within the subnet mask to create 200, let's say you set your, like you can take one class C IP address and turn that into like 200, not one, but like 192.168.5, let's say, .0 and /24. So you have those last 8 octets you could, not octets, but bits you can use for hosts. You can actually use them all for networking and give yourself 255, typically 256 individual networks, and with and that's it. That's the no clients. You don't use that for like a loopback address. You wouldn't use that for actual to give IP addresses to clients. So FA00, FA01, and our line con, our console port, and our VTY connections. So everything in here has been covered in the PowerPoint presentation. Nothing new there. As we discussed earlier, the routing issues that there were. So we're going to try to resolve those if we open up the next PowerPoint presentation. Okay. So there's a lot of different paths, and having routing protocols is essential for this. And you're going to want routing protocols of the same type within your network, okay? If you can. It simplifies things for sure. So the two we're going to be using, I'll show you a quick example of using static routing, a static route, and static routing and dynamic routing, but we use a static route and Ospf, which is a dynamic route as well. Great thing about dynamic routing protocols, they use weights and measures, and they can actually this is not applicable here. This is not like Ospf has its own measuring system, okay, and it'll view every type of connection and give it a value, and always take the quickest path possible. If an Ospf packet comes up to an intersection and he has an option of taking a dial-up modem connection or a fiber connection, it will always take the fiber connection, okay? OSPF, open shortest path first, okay? Finds the fastest way to get from point A to point B. So we'll be using that one, and then we'll be using a static route. A lot of this you guys can just read. I don't want to spend too much time on that. If I was doing a full course, I'd be going through this in depth for sure. But I'm not. Okay, static route. Static routes are very administratively, a lot of administration to manage it. You have to manually configure every fucking route between routers. It takes a lot of time to do it, and if any changes happen within your network, nothing will readjust. Period. You're just fucked. You have to go in and fix everything around what was removed or down or whatever. Static routing isn't always the best, but there is some specific times you'd want to use it. Here's the syntax for doing a static route. IP route, and again, it's programmed in the global configuration menu. IP route, and then your IP address, the subnet mask, and then where you want it to go. Okay, so network, destination network, or subnet, the mask, and IP address or interface name used to get it to the destination. So you're saying all traffic belonging to this network, send it out this port. Okay, that's simple. So down here, router A was configured with a static route. Send all traffic from the 172.16.1.0 network. So any traffic for here coming this way, send it out send it to 172.16.2.1. So you're sending it, that's this port right here, okay? So any traffic that comes in for this network from this way to this router, send it to this port, and then this guy here will figure out what to do with it. Okay, and then on this side here, IP route 172.16.3.0, so any traffic for here, okay, that's on this guy here. So any traffic coming this way into the router for this kind of traffic, okay, send it here, which is going to be this port right there, okay, so send it right there, and then this guy will deal with it. Hope that clears it up. I was kind of messing up what I was trying to say earlier. Okay, static routes are also can be used as a default route, the gateway of last resort. A lot of times you should program your router with a default gateway, not default gateway, but a gateway of last resort. And what does it mean is, if something comes into your router and your router has no clue what to do with it, you put in you just say you just push all that, like any sort of IP address that you don't know where it's going, send it to this device. Okay, so it's take anything that you don't know and push it out to this IP address. Gateway of last resorts. They're on the bottom barrel. So when your router evaluates who to send, or which port to send out packets, it starts at the top and works its way down. And the last thing it looks at is your gateway of last resort. It's like rather than filing it in the shredder, it will push it out to whatever port that you just told it to. Show IP route. I talked about that earlier. This gets into RIP, which we're not doing. Okay, this touches on OSPF. So OSPF likes to work in areas. We talk about areas. OSPF sends out its routing tables and stuff like that via OSPF packets. And when to control the amount of areas and stuff like that information is being distributed, you can configure everything to areas. Okay, so those OSPF packets will only be pushed out to devices that are programmed into that area. Like I said, OSPF, open shortest path first, characteristics, link state protocol, uses cost metrics for path selection, usually bandwidth. Okay, so to actually start programming OSPF, use the command router OSPF and then the process ID. We always use 110 as a process ID, and then the network address and the wildcard mask. Now the wildcard mask is the opposite of an IP address. So this is just so if you have not IP address, I mean the subnet mask. So if I have a network that's 192.168.10.0/24, okay, that subnet mask is in binary is 11111. 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 0, 0, 6, 7, 8. Okay, so that's what it is in binary. The wildcard mask is you just take all the ones and all the ones, you turn those into zeros and all the zeros into ones, and that's your wildcard mask. So this guy, as a normal subnet mask, would equal 255.255.255.0. The wildcard mask, which again you just turn ones to zeros, zeros to ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this wildcard mask would turn into 0.0.0.255. 255. I don't know why I think about that. Another example of one. Let's do one example. So this guy here, 255.255.255. See, 128. Say 248. I want to say this was 0, 0, 0, 0. 0, 0, 0 dots. See, 1. So, any questions? What will wildcard ask? I'm tired. Shh. Again, it's the second time I've done this. You think I'd be better? Oh, actually, no, this is the first time doing this. Yes. Okay, so wildcard mask, just the opposite. Okay, wildcard mask, and then the area. So the area is exactly like what we talked about earlier. So what area is it belong to? We usually program the backbone area or whatever. So, or generally, I think all the time I've seen it's just area 0. It's pretty much D&D standard. Hey, look, it talks about wildcard mask. I should have just kept going. Okay, here's an example here. Router Ospf 100 network, and then so when you program Ospf, you have to identify all of your networks. Okay. So right now on Rod's router, there's 3 networks. Believe it or not, there's the internal network, there's the external network, and then there's the loopback address network. And you need to advertise all 3 of those. Okay. If you don't advertise one of those, then it won't be advertised at all. Some of these show IP route, again, that's really awesome one. The rest, not that important. Alright, so let's get into doing a static route first. So we'll program a static route on one of these devices. Let's say this guy right here. Okay. Enable low. Show IP route. Let's just take a look at it before we modify anything. So if you look, there's 3 directly connected things: our loopback address, the networks on 00 and 01. So let's add a static route. So IP routes, and then the traffic we want to send. So everything in this network over here, which is the 10.0.0.0, 255.255.255.0, and we want to send it. So the next hop for this router, the next hop is this port right there. That's the port you want to send it to. 192.168.0.1. Okay. Then do show IP route. So now we have a static one right now. That's what the S means, static. And so any traffic going to the 10. Oh, I screwed that up. I made it. It's supposed to be a Class A IP address. So let me just fix this. So because you can put in multiple static routes, you can't just put like no in front. Like you can't just overwrite it, I should say. You have to put no in front of it. So there's our command. Let me put no in front of it. And do show IP route. It's gone. Go back in here. It's got to change this. This should be a 0.0. Oh, I need to get that no. There you go. P route. Do. And there's our static routes to our /8 network. Okay, so now if this host here, pings this host over here, that ping will go here, and when he sees it, he's gonna be like, oh, you're trying to talk to that guy from the 10 dot whatever network. Let me see. Oh yeah. I got you hooked. Okay, he's going here, and I know where that is. Okay, so he sent it out, his FA00, and that will come over here. And when he gets it, he's like, cool, I know where that guy is. And this router here will send it out over here, and he will get it, and then he'll send it back, reply back, and when he sends a reply back, it'll get to this router, and this router would be like, I don't know where this network is. This 20.0 network is. I don't know where it is. So this guy is going to shred it. Okay. Now over here on this side, if this guy pings this guy, it's going to go here. It's going to go here, and this guy will just shred it. So that's not going to make a difference there. But from here, though, I should be able to ping back and forth here. So until we get we can get some connectivity going, but until both sides are configured, it's just not going to work. And I'll just quickly run the command prompt. Let's see. Ping 10.10 correction 10.0.0.3. Where are you at? Well, that's just timing out, and I'll continue doing that. Here's an example where I was saying before. Pay attention to it. You got a reply back. You got a reply back from your own router saying destination host unreachable. Okay, it means your router did not know where this guy was. But if you look over here, the request timed out. Your router knew where to send it, and this guy's router didn't. Okay. So now we'll go into this router and we'll add a static route in here. Okay, so again, all the traffic that's going to here, all the traffic goes for here, through here, so we need to identify this network, and then where does he send it? He's going to send it right there, and this guy can deal with it. So everything in the 20.0.0.0, 255.0.0.0, sending it to this port here, which is 192.168.0.2. Okay, show IP, do show IP route. Now we got our static one, so now they should be able to talk back and forth. If not, there's a problem. Top one. And there we go. He should be able to access the HTTP server now. Again, this is this laptop over here, through there, and to there. So if I go to my desktop, open up my browser, 10.0.0.0.250. Boom. He's up. Okay. As you saw, though, this is not a very good way to manage it. If you had something like this here, okay, which we're going to add in a bit. If you had that, all those individual static routes are a pain in the butt. If a router gets replaced or new infrastructure gets added, you have to constantly keep adding more static routes. It's a pain in the butt. So you want a routing protocol that's dynamic and changes as the network changes. Hence Ospf. So we just need to go in, just undo what we did, and we'll add in Ospf. Okay. As you see, the static routes are gone now. Gone. So let's add, we'll add Ospf on here first. Router Ospf. Let's say we'll use what they used, 100. You have to identify every network that you have, and you have 3 networks. 1, 2, 3. Add them all. Network 10.0.0.0. Wildcard mask, right? Wildcard mask should be 0.255.255.255 area 0. Okay. So again, this is his networks. Network. This is loopback address network. 0.00.1 and 0.0.0. 2, 3, 4 zeros. Okay, and area 0. Network 192.168.0.0. 2.5 area 0. There we go. So it's programmed on this one now. Oop, not you. It's programmed on this one. Ospf 100. Network 20.0.0.0 and 255.0. No, that's right. 0.255.255 area 0. Now they're both advertising this network because they're both a part of that network, so that's normal. Okay, let's do show IP route. Okay, so our route table is already updated. The nice thing about Ospf is it won't trigger. What happens is every time a network change happens, and only when a network change happens, the network sends out packets like the routing tables everywhere, so that everybody can see what the network change has, and it's good. It's for low maintenance. So it's already happened. Like they've already sent the change, and there's they've sent out the packets. Now, if you look right here, this one now knows where 10.0.0.0/8 is, or sorry, /8. And it's via fast Ethernet 00. Okay? And it knows where the loopback address is as well for that router. And then if we were looking to the other one, he has the other one now. He has the 20.0 and the loopback address for that one as well. Okay, and now we just got to quickly go into this router and just check that we do in fact still have access to the HTTP server over here from this guy right there. Cool. If you have any questions with this, let me know. Next, we'll try to do VLANs. I'm not sure if we'll do that. I need to configure Ospf in this cloud, and then I'll add the cloud in. Just to make things a bit more interesting, I'll add the cloud in right here, and then which will change this, and you'll see a whole bunch of Ospf networks and everything in there. It'll be good. All right, until next time.